Objective, multi-step equations with combined like terms, distributive property, and variables on both sides. Let's go over a definition. Identity, an equation that is true for every value of the variable. For example, the equation 2x equals 2x. Notice I have the same thing on both sides. So no matter what x is, it's being multiplied by 2 on both sides. So that equal sign is still going to be true no matter what value x is. That is called an identity. Steps to solving multi-step equations. And again, with multi-step equations, notice we're dealing with a handful of different types of multi-step equations. So if we have parentheses, we're going to use the distributive property to remove those parentheses. If we have like terms on either side of the equal sign, we're going to combine those like terms as far as simplifying each side of that equal sign. Get the variable on one side of the equal sign and the constants on the other. So if I have variables on both sides, which is what VBS is, variables on both sides, then that means I've got to move my variables to one side and all my constants to the other. Then you will start beginning that inverse operation process. Start undoing the addition or subtraction and undoing the multiplication and division. All right, Vic number 1. An equation has no solution if no value of the variable makes the equation true. So like for example, here 2x equals 2x plus 1. Notice that on this side I don't have a plus 1, but on this side I do as far as the x goes for the 2x. So no matter what I put in here for x, it's not going to make a true statement. So therefore there is no solution for that particular equation. Let's go over some examples. Here you can tell I have parentheses. For example, number 1, 6 multiplied by y minus 1 plus 8 equals 32. So what this means is I do have the parentheses here. So we need to perform the distributive property in order to remove those parentheses. So 6 times y is 6y. 6 times negative 1 is negative 6. The plus 8 comes down and also on the right hand side. Now where we get, I do have like terms here. My constants are like terms. And so positive 8 and negative 6, they give me a positive 2. Notice I brought the 6y down since we didn't have to do anything to that. Subtract 2 to both sides. And then 6y equals, well, 32 minus 2 is 30. And so we always divide when I have multiplication. To undo that, we always divide by the coefficient. So when I divide by 6, 6 divided by 6 is positive 1y. And then 30 divided by 6 is positive 5. So the solution to this equation is y equals 5. It has one solution. 5 is the only value that can be plugged into this equation to make it true. Example number 2. 3 times 2y minus 4 plus 4y equals 8. So again, parentheses. I know I need to distribute to remove those parentheses. So 3 times 2y is 6y. 3 times negative 4 is negative 12. Again, bring down the 4y, the positive 4y. And notice here, I don't have constants the same, but I do have like terms as far as the variables. They do have the same variable factor, the y. So I know I combine them by looking at the values of the coefficients. Here's a positive 6, and here's a positive 4. That's a positive 10y. Okay? Negative 12 comes down, and then that equals 8. Now I'm ready to undo adding or subtracting. So I need to add 12 since I have subtraction of 12 to both sides. That gives me positive 10y equals positive 20. Always divide by the coefficient. And y equals positive 2. Again, I have one solution to this equation, and that is y equals 2. All right, let's do some practice. You notice every single one of these examples, I do have parentheses. Some of them I might need to combine certain terms once I distribute, And then it just depends on what is, given to me once I remove the parentheses. So example number 1. Remember, there's that understood 1 sitting out there, so I'm going to treat that as a -1 when I multiply that negative through. So -1 times x is -1x. -1 times +5 is -5. And then I'm ready to bring down the -14. Now I'm ready. I don't have any like terms. I don't have variables on both sides, so I'm ready to undo the addition or subtraction. I do have a -5, so that tells me I need to add 5. So when I bring down the -5, +5, add up to 0, bring down the -1x, that equals, well, -14 and +5, that equals a -9. And again, I do not have a +1x here. I have a -1x. So we can't stop. We need to divide by that -1 coefficient. And -1 divided by -1 gives me that +1x. -9 divided by -1 is +9. Again, this one has one solution, and it's x equals 9. Example number 2. Same thing. I do have that understood 1 sitting out there, and it's negative. So when I distribute through, I need to make sure I distribute a -1 through. So -1 times 2y is -2y. -1 times -3 is +3. Okay? I do have like terms on the same side. And so when I combine them, I have a +8 and a -2. So that gives me a +6y. Bring everything else down. Okay? At this step, I see I have addition, a +3. So I need to subtract 3 from both sides. And that brings my 6y down. 9 minus 3 is +6. Now I'm ready to divide by my coefficient. 6 divided by 6 is +1y. 6 divided by 6 again is that 1. And as you can see, this makes a true statement. Y equals +1. It has one solution. Example number 3. I have parentheses, so we need to go ahead and distribute that 4 through. So 4 times x is 4x. And 4 times +5 is +20. Now notice I have variables on both sides. So it told me I need to bring my variables to one side and my constants to the other. So here I'm going to subtract 4x. Since it's positive, I have to do the inverse operation, which is subtraction. So on the right hand side, it goes to 0, so I need to bring my 20 down. And then on the left hand side, it's +6, -4. Combine those like terms, that gives me 2x. We always divide by our coefficient, +2 here. 2 divided by 2 is +1. And then 20 divided by 2 is 10. Again, one solution that does make a true statement. All right, a few more of these. So here, I notice I have like terms on the same side. So I have a +1x and a +3x. Combine those, it's +4x. This -7 comes down. All right, now I'm ready. I don't have parentheses, I don't have any of that. All I had to do was combine my like terms. So now I'm ready to begin the inverse operations. So I had a -7, so I know I need to add 7. So 4x, and then 29 plus 7 is 36. Now I'm ready to divide by my coefficient, and my coefficient is +4. And 4 divided by 4 is +1x. And then 36 divided by 4 is +9. All right, again, I had one solution here that made a true statement. All right, let's look at number 5. I don't have anything over on the left-hand side of the equal sign, but I notice I have 3 different, like terms on the right-hand side. So 1 plus 3 minus 2. When I combine those, that gives me, well, 1 plus 3 is positive 4, minus 2 is positive 2. Okay? Now, I end with where I have variables on both sides. So again, I need to move variables to one side. So here I have a 4p. I'm going to bring it over to the right-hand side. So positive 4 and negative 4 add up to 0. Negative 10 comes down, and this is a negative 2. My coefficient is negative 2. And negative 2 divided by negative 2 is positive 1. Negative 10 divided by negative 2 is positive 5. Again, I have one solution to this equation. All right, last 3 examples. These 3 examples, notice I'm asking you to identify the solution. So all the other ones that we've been dealing with have been where we see one solution every single time. That might not always be the case. With equations, you might have one solution, which it will be given, or you have infinitely many solutions, or you don't have any solutions. In other words, it makes a false statement. So I'm going to present you all 3 types. So example number 1. So again, I see parentheses, so I need to remove those parentheses. So 3 times 6x is 18x. 3 times negative 2 is negative 6. I don't have anything going on that I can simplify. Now I need to start moving my variables to one side. So I'm going to subtract 18x over here, bring it over to the left. Notice it's positive, so I have to subtract it. By doing that, notice my x's go away. Negative 5 comes down, and then negative 6 comes down. Is that a true statement? No. This does not make a true statement. Therefore, this is not true. Therefore there's no solution. That goes back to that Vic number 1 that we talked about. So that is what that would look like, where you have a false statement. That is something that's not true, therefore there's no solution to that equation. All right, example number 2. No parentheses, but I do see where I have variables on both sides, so I need to begin that process of moving them. So I'm going to subtract 2a. Okay, by subtracting 2a, it simplifies the 0 on the right, bring positive 9 down, and then I get a positive 3a. Now I'm going to bring my 9 over. I need to subtract since it's positive. And again, it goes to 0 on the right-hand side. Divide by coefficient. Positive 3 divided by positive 3 is positive 1a. And this is possible, right? 0 divided by 3 is 0. That is possible. That is mathematically possible. Now this had one solution. So this is the types that we have always seen. All right, so this is has one solution. That one had a false statement, so it's not true. There's no solution. So let's look at the last example. I do have parentheses. So remember, there's that negative 1 sitting out there. If I had a plus sign, that would be a positive 1 that I would distribute. So let's go ahead and distribute to remove those parentheses. So negative 1 times 2q is negative 2q. Negative 1 times positive 5 is negative 5. All right, let's go ahead, and I see I have like terms on the same side. So a positive 14 and a negative 5 is positive 9. I can stop here if I would like. I notice that I have negative 2q plus 9 on the left side. On the right side, I have negative 2q plus 9. I have the same thing on each side. This is an identity. This means that I have infinitely many solutions. No matter what I do to q, it's going to be being multiplied by negative 2 and then adding 9 to it every time. Well, let's go ahead and finish it out and see what that looks like. I'm going to add 2. So I get 9 equals 9. That is a true statement. So this is an identity. And how many solutions does that have? Infinitely many. No matter what I put in there for Q, it's going to be true, no matter what. There's not just one answer like I have here for problem number 2.